linear programming is not a very big stretch from what we were doing yesterday. Yesterday we were solving a system of inequalities and finding out where those inequalities overlap, what were the vertices of that figure. Today we add one more step to it. So we're going to graph x greater than or equal to 0, y greater than or equal to 0, x plus 3 less than or equal to 6, and 2x minus y less than or equal to 5. Okay, so let's use our vertice method, right? Or not our vertice method, but our intercept method to figure out what our equations or what our ordered pairs are going to be for this. So if x is 0, what will y be? When x is 0, y is 2. And when y is 0, x is 6. All right, this line, when x is 0, what's y? And when y is 0, 5 over 2. 5 halves, 2 and a half, 2.5, whatever you like. Okay? So that helps us figure out where to put our axes. We know that we need to go from -5 up to 2 from an x standpoint, and from 6 down to 2.5. Okay, so we can let our coordinates be 1, 2, 3, 4, 5, something like this. So we need to have a -1 and okay, so if we are bigger than 0, bigger than or equal to 0, we know that we are going to need to go solid line, right? On 1. Solid line, bigger than or equal to 0, going this way. And bigger than or equal to 0 for the y values means I want a solid line going that way. Okay. Now we plot our point 0, 2, and 6, 0, connect the dots. And we want it to be less than or equal to this line. So do we need a shading toward the 0, 0 or away from it? 0 plus 0, is that less than 6? Yes, so we want to go toward the 0, 0, right? Toward the origin. Then we want to plot 0, -5, and 2.5, 0. Equal to means we have a solid line. Do we include 0, 0 in our shading? Yes, because 0 plus 0 is less than 5. So we want to go in this direction. Okay. So once we've done that, we know we're shading in the first quadrant based on the x and y being greater than 0. We know we're shading in this direction for x, and so this is our final answer. Okay. And what we're interested in are those vertices. Okay, where do these guys intersect? So this is the point 0, 0. And this was the point 2.5, 0. And this was the point 0, 2. Where do the red and the blue line intersect? Looks like 3, 1. Let's verify that that's exactly 3, 1. So is 3 plus 3 times 1 equal to 6? 3 plus 3? That one works, right? And 2 times 3 minus 1, they both work, right? So we know that 3, 1 is our other coordinate, our other vertex. So that's what we did yesterday. Now today, What do you think we're going to do if we want to find the maximum value of z equals 2x plus 7y? Absolutely. We're going to plug them into the x and the y's that we have from our ordered pairs into this equation and figure out which one gives us a maximum. So when we plug 0, 2 in, 2 times 0 plus 7 times 2, because we're plugging in 0, 2, is equal to what? 14. When we plug in 3, 1, we'll get 3 times the 2 plus 7 times the 1, and we get 13. We'll plug in 2.50, and 2 times the 2.5 plus 7 times the 0 gets us 5. And then lastly, we'll plug 0 and 0 in, and 0 times 2 plus 7 times 0 gets us 0, right? Which of them gives us the maximum value? 0, 2. So 0, 2 has the maximum value, and the maximum value is 14. Potentially, the problem is, so the question is, can we just, if we have it, can we just pick the highest point? We can most likely, yes, discredit 0, 0. Not going to happen, right? But it depends on what's happening here. Because the 7 was being multiplied by the 2 that had more power than the 2 being multiplied by the x, right? So that's the reason that one was bigger. Okay, had it intersected up here at, you know, 2 and 3 or something like that, then that would have given it more power to be the higher. But yes, you can use your common sense when you're plugging points in. Okay? Other questions about this slide? So no big stretch, right? More practice of what we did yesterday, making sure we're good graphers, using our intercept method, because in a lot of cases it's going to help us figure out how big to make our graph, where our axes should be, and then we plug numbers in to see what happens. Okay, let's do another example, unless you don't want to need to see another example. Or we feel comfortable and confident we're okay? Want to see one more? Okay, let's do one more. If you don't need to see another one, you're certainly welcome to get started on the assignment. It's going to be section 7.6. The bold-faced ones are your required. 11, 15, 37, 39, and 40. So just 5 required problems out of a problem set of 8. Okay. And all we're doing is finding the vertices. Okay. Now, if you wanted to see this one, same idea, right? Okay. But they weren't quite as nice of numbers, are they? Because we're dealing with 45s and 60s, aren't we? Okay. So again, I would always recommend plugging in 0 for x, seeing what y happens to be, and 0 for y, seeing what x happens to be. Does anybody want to see this worked? Yes? Okay, let's do that. All right, so we know x is between 0 and 60, y is between 0 and 45. And when we let x be 0 in this equation, this inequality, we will have a 6 times y is 420. So we divide and y becomes 70. Then when we let y be 0, we need to find out what x is. And 5 goes into 420 84 times. Okay, I think it's 84. Someone check my mental math. Okay. Then we're doing the same thing with the next equation. When x is gone, x is 0, then y happens to be 20. And when y is 0, then x happens to be 10. So now we know roughly how big we need to go. Our y's have a max of 70. Our x's have a max of 84. We don't have anything negative. So our axes, x-axis, y-axis, and then maybe by tens. And same thing on the x-axis or the y-axis. Okay. Now, this first inequality is saying x has to be between 0 and 60. Bigger than 0, less than 60, or equal to. So between 0 and 60, we would have a solid line, and we know we're shading in the to the left. Between 0 and 45 for the y's means that we're going to have a solid line here and shading down. Okay, so those are our boundaries, in addition to x being bigger than 0, y being bigger than 0. So we're in this little box. Okay, the little green box. Now, let's plot our other two lines. 0, 70 by plotting points, and 84, 0. Connect with a solid line, preferably a straight one. And then we ask ourselves, is 0 plus 0 going to satisfy that equation? And it will, so we want to shade toward the 0, 0. Okay. Now, plotting our red line, 0, 20, 10, 0. We have this itty bitty little line right here. Okay, so we need to find out if this guy, 0, 0, is going to satisfy this equation, and it's not. So we don't want to go in the direction of 0, 0. We want to go away from 0, 0. And now we see where all of this is going to come together. This is going in this direction. So here is our here's our figure. Okay. So what we're concerned with are those vertices. We know that this one was 45, 0, 45. We know this one was 0, 20. This one was 10, 0. We had a 60, 0. When x was 60, we crossed our blue line. So when we put 60 in for x, 5 times 60 is 300. So 420 minus 300 is 120. 120 divided by 6 is 20, right? So when x was 60, y was 20. Okay, didn't look like I did a very good job of drawing a straight line there, did I? Should have crossed right here. Okay, and red line, we need to figure out where red line met this green line. So where did this guy, actually we're okay on red. We need to find out where blue line met the y of 45. So where does this blue line meet 45 for y? So 6 times 45, how much? And 24, so 270? And then you've already taken away your 270 for me. So 150, yep, x is 30, thank you. Wasn't very quick with it, as quick as you were with the calculator. All right, so this was the point 30, 45. So then our job is to take 1, 2, 3, 4, 5, 6 points and plug it into this equation. Okay, now, as Caitlin was saying earlier, if I take a positive number and a positive number times these numbers, and I'm trying to find a minimum value, do I want these out here? Probably not, right? These guys are probably going to be the bigger ones. So you can use some common sense and say, hey, maybe I'll just try the 60, 0, the 10, 0, and the 0, 20 to find my minimum value, because these should have be more likely to be the minimums than 60, 20, 30, 45, 0, 45, and so on. So you can use a common sense approach to that. If I don't see all of these tried, that's okay, as long as you find the right minimum or maximum, as the case of the other one happened to be. Make sense? Anybody want to see me plug them in? Or you're good? Okay, we're good. Awesome. Okay, you've got the assignment. We'll go over questions from yesterday in just a moment.